Okay, there's one super important topic that was in chapter 2, which I skipped in the favor of time, I guess saving time, is polarity. So I need to discuss that first, and I need you to make sure that you understand this topic and the properties that result from polarity before you start reading on the molecules of life next week, because polarity is going to come up like pretty much forever now in both biology and chemistry. So whenever I say something is polar, I need you to understand what that is. So first thing I want you to do is to look at the word polarity. In English, when you have ity at the end, it's the ability. I don't know if that's where ability comes from, but usually that's what that means. And so, or having the property of, maybe. Polarity is having the property of being polar. And when you have AR, the combination AR at the end of a word makes it an adjective. And so we're really talking about an adjective that describes something of having the property of poles. So if I ask you to name something that you would associate with the word polar, you might think polar bear. And why do we call a polar bear a polar bear? Because where do we find polar bears? At the North Pole. And why is it called the North Pole? Because there is an equal and opposite end, the South Pole. And there is the key to what describes polarity, having two opposite ends. And so the quintessential, or the most basic molecule that we use to describe polarity is the molecule that you see on your screen, which is water. Water is one oxygen and two hydrogen atoms. The oxygen has a covalent bond with each of the hydrogen atoms. A covalent bond is where electrons are shared. That's my abbreviation for electrons, E minus, because electrons have a negative charge. I'm hoping this is not news and that you understand that already. So in the single line that I draw between oxygen and hydrogen, that represents a covalent bond where electrons are shared between oxygen and hydrogen. And here's where polarity comes in. So you might be asking yourself, okay, polarity is having two opposite ends. Well, how can you have opposite ends with a water molecule? Well, for polarity, when it comes to chemistry, it's describing the electrical charge or the distribution of electrical charge. So let me start with this. If you have a periodic table, I don't actually think I have one, but I can get one because I have Google. Oops, that's going to come up next. Periodic table. This is what happens when you just start recording and you don't actually think about what you're going to do step by step. That picture is not clear, so let's, okay, clear. So hydrogen, you can see in the top left corner, it has a little number 1 in the top left corner. Oxygen all the way on the right-hand side has a little number 8, okay? So I want you to remember that. I'm gonna come back here and I'm gonna go, hydrogen is a 1, oxygen is an 8. Now, what those numbers represent is something called atomic number. It means the number of protons that are in the nucleus. And I hope that's not news to you. That should be something that you covered in somewhere between grade 7 and grade 9 science. So the number of protons, and protons in an atom do have a positive charge. So basically what we're looking at for charge, because polarity is talking about charge, hydrogen has a nuclear charge of +1 because it has 1 proton in the nucleus, and oxygen has a nuclear charge of +8. Now, why does that matter? Well, going back to my covalent bonds, we're talking about electrons. Electrons have a negative charge. And what do we know about negative and positive? They attract. They have a force of attraction between them. So we say electrons are attracted to protons. Now, if electrons are negative and protons are positive, therefore electrons are attracted to protons. Now let's go back to my atomic number. Hydrogen is +1, oxygen is +8. Which one of those two do you think electrons are more attracted to? +1 or +8? Would you rather have $1 million or $8 million? 8, duh. So the electrons spend most of their time around oxygen, and when they come down to hydrogen, they only stay there for a little bit, maybe the weekend. Same thing over here. The hydrogen atoms are shared between the oxygen and the hydrogen, but they spend most of their time around oxygen. Now, what does that do for charge? Let me get rid of these. Okay. What that means is that because electrons spend most of their time around oxygen, oxygen takes on a slightly negative charge. Now, that weird squiggly that I wrote, see if I can do it nicer, something like that. That, I believe, is lambda, which is a Greek letter. If any of you guys know, let me know. I don't ever bother to remember that because it doesn't really matter. But it is a Greek letter which in chemistry means a partial. So the word partial meaning part of, not a whole. So this partial negative means that oxygen is a little bit negative because the electrons are around here most of the time. That also means that each hydrogen takes on a partial positive charge, okay? So now this is the key to polarity. Let's go pink. If I split my water down the middle, now we get to the main idea of polarity. You look at the top half of the molecule, it has a slightly negative charge, and the bottom half of the molecule that has a slightly positive charge. Everybody okay with me so far? So electrons are shared because they're shared between, it's kind of like when parents get divorced and they have to share the kids, right? But they're not shared 50-50. So like maybe dad gets them during the week and mom only has them on the weekends. It's like that. So dad sees the kid most of the time. In this case, oxygen is dad and hydrogen's mom. Just, you know, as an example. Okay, so I've written all this out before because I did a whole video that just ended up being a hot mess. So I decided to start over. What I've done here is I've drawn 2 water molecules. And now I'm going to explain what happens, because when you get a glass of water or a bottle of water, you're not just getting one water molecule, you have like gazillions of water molecules. So what happens when a bunch of water molecules get together? Well, you've got this hydrogen on that water molecule that gets slightly attracted to the oxygen atom. I think I said hydrogen molecule. Ugh. You know what I mean? The hydrogen atom on one water molecule is attracted to the oxygen atom on the other water molecule. So you get this, which I don't know if you can see that. It's called a hydrogen bond. A hydrogen bond, very similar to covalent bond, ionic bond. The only difference is a hydrogen bond is an example of an intermolecular force. Okay, intermolecular, there's that AR again, making it an adjective. So you turn molecule into molecular. That's an adjective which describes the forces. So what does inter mean? If you go on an international flight, you already know in your mind that means that you're going to a different country. That's inter, 2 different things. So in this case, different molecules. Okay, it's all kind of a game of translation. So the AR makes it an adjective. It's describing a force involving molecules, but different. So a force between different molecules. That's an intermolecular force. For the covalent, we've got 2 types of bonds which hold compounds together. You've got covalent, which is sharing electrons, ionic, which is one atom giving electrons away to another atom. Those are called intramolecular forces. Intra meaning within. So the covalent bonds here, these are intramolecular forces. They are holding one molecule together. Hopefully everybody's with me so far. If not, please pause, rewind, replay, and if that fails, get online and start asking me questions because I can answer them. Now, here's the key to why this matters. One of the things that I will try really, really hard to do is to make what you learn relevant to your life, because there's nothing worse than learning stuff and being like, when the heck am I ever going to use this in my life? Well, polarity is really important, and I'll get to, there's several reasons why, but I've drawn this flowchart kind of explaining how polarity is related to hydrogen bonding. And then there's 4 main properties of water that result from the hydrogen bonding, which results from polarity. So polarity creates hydrogen bonds, and hydrogen bonds create these 4 properties. We have cohesion, number 1, adhesion, number 2, capillarity, number 3, and the most important one for biology, and the only reason why any of us are alive now, is temperature moderation. So I'm going to do a separate video doing those 4, because I haven't actually thought about how I'm going to do those 4, and I'm just going to end up screwing it up again. So hopefully this video helps you understand polarity.